Welcome to Pomodoro Joe for Friday, May 12th, 2023. Today we're doing LeetCode problem 2140, solving questions with Brainpower. This is a medium problem. You are given a zero-indexed 2D integer array, questions, where questions index I is equal to points and Brainpower. All right? The array describes the questions of an exam, where you have to process the question in order, starting from question 0, and make a decision whether to solve or to skip each question. Solving question I will earn you points at index I. But you will be unable to solve each of the next Brainpower index I questions. If you skip question I, you get to make the decision on the next question. For example, given questions 3-2, 4-3, 4-4, 2-5. If question 0 is solved, then you earn 3 points. But you'll be unable to solve questions 1 and 2. So you have to skip 1, 2. If instead question 0 is skipped and question 1 is solved, you will earn 4 points. But you will be unable to solve questions 2 and 3. Return the maximum points you can earn for the exam. All right, so let's break this down really briefly. So essentially you're given a list of points and Brainpower that each question will take in an exam. You have to solve the exam questions in order, but if you solve a question, you earn that many points, but you need to skip the next Brainpower questions. So there's a trade-off. All right, so let's solve this recursively. We'll start the Pomodoro timer and we will get started. So we will have some result and that will start at 0. And we will return the result at the end. Now, I think I'm going to solve this using an internal recursive function because we don't need to actually keep track of a new list each time. We just need to keep track of the question that we're on. So that's going to be an index. So in fact, I am going to move these inside a new function that we'll call mostPointsRecurse. And that will just take the index of the current question that we're processing. All right, so how does this work? Well, we have two options at any given index. We do the problem or we skip the problem. That's basically what it comes down to. All right, and we still need to come up with our base case. I should have done this first. So the very first thing you always do when you're building a recursive function, you write the base case. So what's the base case here? Well, the base case will be when we run out of questions to answer. And that happens when our index is greater than or equal to not just greater than. That happens when our index is greater than the max index. So let's create our max index out here so we don't have to recalculate it every time. And the max index is just the length of questions minus 1. Okay, so now our base case. If our index is greater than our max index, well then we're done and we return 0. So at this point, we have an index for a legitimate question. We have two options. Option 1, we just skip this question and go on to the next. Option 2, we do this question, but that means we can't do the next Brainpower questions. So let's unpack this a little bit. We have option 1, and this is, we just skip this question. So we can actually call our mostPointsRecurse on index plus 1. Because we're going to skip the question at this index, so we just move on to the next question. All right. Then we have option 2. Before I do option 2, let's unpack our question here. So we have points and we have Brainpower. So this will just pull out those two elements of our question. So option 2, well, we're going to do this question, so we get these points. But then we can't do the next Brainpower questions. So we get these points, but then we can recurse passing in index plus Brainpower because we have to skip Brainpower questions. And I think we might need to add 1. So let's see. If it says, if our Brainpower, for example, is 1, we get this question, which will be at our index, plus 1, which means that's the next question, but we have to skip that question. So we actually need Brainpower plus 1. So it's index plus Brainpower plus 1. All right, so option 1, skip the question. Option 2, do the question, but then we have to skip the next Brainpower questions. And finally, our result, well, we'll just return whichever one gives us the most points. So we'll return our max option 1 or option 2. So in fact, I don't need this result. I can just get rid of that. And we'll just return max option 1, option 2. I think that's our function. Now here we do need to actually call this function initially, so we'll return this function passing in index 0 as our starting point. All right, let's just run through this really quick and then we'll give it a shot. So we have our maximum index here and we have our recursive function. It just takes an index and we say, if this index is greater than our max index, we've gone out of bounds, we're done, we just return 0. You can't get any more points. Option 1, we actually choose to skip this problem. So we don't do anything, we just call the recursive function on the next index. So we move on to the next question. Option 2, we actually do this problem, so we get the points, but then we need to skip the next Brainpower questions, so we call the recurse after skipping the next Brainpower +1 question. Or I should say the index +1 plus the Brainpower questions. And then at the very end, we just return whichever one gives us the best answer. Okay, let's try this. Oh, because I need to do questions at this index. That was silly. All right. Okay, and we pass. Let's submit that, see how we do. Now I'm guessing we won't do this in the time limit we need. So there's a simple fix for that, and I'll show you in just a second, if we need to. And we need to. Time limit is exceeded. So we'll use this test case and we'll just patch this up a little bit. So the simple thing here is to use dynamic programming or caching. So in this case, because we're just passing in an index, is a very simple function in terms of the arguments that it takes. So for example, if we pass in 2 for this index, we'll always get the same answer. We can pass in 2 and we'll get the same answer. If we pass in 2 again, we'll get the same answer. If we pass in 3, we'll get a different answer from 2, but we'll always get the same answer for 3, which means that we can actually cache that answer and reuse it if we ever need to get that answer again. So with these recursive problems, generally we'll be calling the same function with the same parameters multiple times. So by caching the answer one time, we'll be saving a bunch of processing for future calls with that same argument. Now, a simple way to do that in Python is to use functools. So from functools, we will import cache. And cache is just a function decorator that we can put before our function here. We use @cache. And this will actually cache out the values. So when you run this function one time with a given input, it will run the function the first time, but then it will cache the result. Next time you call it with the same input, it will just return the cached result and it will skip the processing. So this should save us a bunch of runtime. And it does. Let's see if this will pass all the tests. And we pass. We don't do a great job here, but we do pass. So we beat 5% for runtime and 16% for memory. So it works. It's recursive. It's simple to understand in terms of conceptually how it works, but it's a little bit tricky to get everything working just right with the caching. So let's jump back and see if we can improve on this. There are some simple things we could do in here. If you've watched my other videos, you know we can change this max function call to our own function call, or instead of doing a function call, we just do our own if then or if else right here. If we do our own if statement here, we could save a little bit of processing. Well, there's time, let's do it. All right, so instead of doing max here, we'll just return option 1 if option 1 is greater than option 2, otherwise we'll return option 2. So this is our own version of the max function. It saves us a function call, which means it should save us some processing time. Seems to still work. Let's see if it saves us anything. And it does. We double our speed. We're at 12% up from our 6% before, 5%. So yeah, it does. It helps, but it still doesn't get us near the percentage that I'm looking for here. So let's jump back and try this again. Scrap the recursive function and try again with an iterative function. All right. Actually, before I do this, I'll point out a couple things with this function. So one thing we're doing here is we're going to be essentially calling this function down the line. We'll be passing in more and more greater indices to find the points that we can get from future questions or future indices. Then when this returns, we will essentially be passing that result back up the chain. So these, I'm not explaining this very well. In recursive functions, you recurse down to your base case, then you return everything back up the chain until you get to your first function call, which will return here. So when you're doing that, you're essentially passing the results from these future function calls back up the line to the previous function calls. Now, we could do something very similar by keeping an array of all of the results from all the potential indices. It's not making a ton of sense, but maybe I'll diagram it out and maybe it'll make more sense here. So let's start this whole thing over. We don't need any of this. All right, so let's do this iteratively. Now, instead of having one result at the end, we are going to keep track of the results for every index in our potential questions. So we'll have a results plural, and that's going to start as an empty array. And at the very end, we will return our results at index 0 or index -1, depending on which way we end up doing this. I am going to actually return results at -1 because I think that makes this easier. So one thing that happens, if we are at question 1 or question 0, so we're at question 0, if we do this question, then we have to skip the next n questions, the next Brainpower questions, and look at the result for that index, the best answer we can get for that index. Now, if we've calculated that, let's just say we've calculated the best result for, in our case, let's try this one. So we can take 3 points, but then we have to skip 2. So we go from 0, we go 1, 2, and then we can do the question at index 3. So we could just grab these 3 points and say, all right, I'll take these 3 points plus whatever is at index 3. Now, at this point in our array, we don't have anything at index 3. But if we had calculated everything at index 3, we could just add those points and say, well, that could be our best answer here. Same thing with the next question here down the line. We can grab these points and then look ahead to our index that we can get points from and see what are the best points there. So we're kind of looking ahead to see, well, what were the best points I could get for these future questions? Now, it's a little bit tricky to do this in the forward direction, but imagine you do it in the reverse direction. If you start at the very last question, how many points can you get from that very last question? Well, the best you can do is actually the points for that question. Because no matter how many questions you have to skip, there aren't any future questions. You can't do any better. So we can actually tell what the best points are for the very last question right away. Now, what about the second to last question? Well, that's either the best we can get from doing that second to last question, and potentially if we have a 0 Brainpower question, maybe we could get something from the last question itself. But most likely we'll have to skip the last question and there are no future questions. So the second to last question is probably just those points that we can get from doing that question. Or you can skip the question and get points from the very last question. So I am just butchering this, but let's see if I can write this out and maybe it'll make more sense. All right, so the first thing I'm going to do here, I want to go through our array backwards. So I'm going to reverse our questions. Now, to reverse an array or a list in Python, you can just slice it with a -1 step. So these reversed questions are just this initial question array reversed. All right, so now I want to go through all of these questions for every, and I'll keep track of my index and my question. I'll just call it Q. And the enumerated reversed questions. Okay, so I'm going through all of my questions in reverse. So I'm looking at the last question first. I'm keeping track of the index and the question here. And let's see, I'll pull out the points and the question or the Brainpower. So points brainpower. And that's going to equal our question. All right, so now we have two options at this point. We do the question or we skip it. Now at the very last question, we don't really have an option to skip it because we won't get any points. So we basically have to do the last question. So what's our best answer for the last question? Well, that's just points. All right, so let's see. We'll take these points. So option 1, we'll take the points. But let's see, if not result. So if we have an empty result, we'll just take the points. Else, option 1, we skip this question and we don't get any points. Option 2, we do this question, we take the points for this question plus whatever points we can get from the future question. In this case, it's a little bit backwards because we're looking at the future in terms of questions we've already done in this reversed question array. Yeah, this is confusing. So our next question index. Well, let's see. If we do this question, we cannot have done or we cannot do any questions past our brainpower. So we have to look at our index, which is our current index, I, minus this brainpower. And similar to how we had to do the +1 with the recursive function call, we have to do a -1 here. We're looking backwards here because our array is reversed, but that's the same as looking forward in the non-reversed array. So I is our current max index. Our brainpower will be how many questions we had to skip. So when we're looking backwards by our brainpower in our reversed array, that's the same as looking forwards in our non-reversed array. Okay, so now our option 2 here, well, this will be taking these points for doing this question, plus whatever points we can get from doing that future question. But in our case, because we're going backwards, it's kind of like we're going back in time. We've already calculated these future questions and they're already in our results. So we can look at our results at this next question index. But then we still have the same issue where we have to take the max of option 1 or option 2. Now in this case, we can actually just append our result here. And that's going to be the max of option 1 or option 2. All right, let's see if this makes sense. So we're going to reverse our question. So we're actually going from the last question to the first question. Then, starting at the last question, going in reverse order, we're going to grab our brainpower and our points out of that question. Our first option, we skip this question. So now we can just grab the points from this question. We grab the points from this question if we don't have any results. Otherwise, I think I got this wrong. Otherwise, we can take whatever we had at our results at this index -1, or whatever's at the last the last question we did. All right, so our option 1, we take these points, but only if we don't have anything in the results, because this was the last question. There are no future questions, we just take the points. Otherwise, we don't take any points from this question, but we can just look ahead at, or backwards in this case, at the next question and take those points. So this is the same as skipping the question in the forward going array. All right, option 2. We are going to take the points from this question, but then we have to look at our future question, in this case backwards in the array, to see what our best option was there. And we've already stored that option in our results, so we can just grab it at this next question index, which will be our current index minus the brainpower -1. I encourage you to look at this, draw it out on paper, because this is confusing. And then finally, we'll append this result, the maximum of option 1 or option 2. We'll append that to our results. At the very end, we just return our results at the very last index because that will match our first question. All right, I know it's confusing. Let's just run it and see if we completely break everything. And we do. Let's see, index out of range. Oh, yes, that is definitely possible. That's only if this next question index is greater than 0. Yep, I needed to put some guardrails on this thing. All right, so if we are back behind our previous question, we can only take points from this question. I'll need to wrap this thing in some parentheses. Try that. And I do mean results. This is what happens when I try to talk really fast and write code really fast and explain complicated subjects like this one. Looks like we are 1 off. What are we missing here? Oh, if it's less than or equal to 0. So many mistakes. Why do you even watch these videos? And we pass. All right, let's see how we do. And we do well. So we get 80% for runtime and 54% for memory. That's a huge improvement over our recursive function, which at best was 12%. So 80%, let's see if we can improve on this, because I think there are things we can do, like this max operation. Let's fix that guy here. Still works. Let's see if that saves us anything. And we're above 90%. 91.36% for runtime, 54% for memory. That is a win. Now there are certain things we can still do in here, like we can clean up some of this. Like, what if I just made this P and B? And we can add here, just cut down some of these things. Just make these a little bit easier, and I'll just call this index instead of next question index. I can't call it I because I've already got an I being used here. And what else can I do? I think that's not too bad. Just clean that up a little bit. Let's see if that still works. I'm looking for a small gain here. Let's see if we can get a 93%. And we're at a 95% for runtime and a 62% for memory. That is a win in my book, and we are out of time. So I hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.